Okay, I think I'm going to get started. The folks are still sort of trickling in, but the numbers have slowed down a bit. So, welcome everybody. Thank you for joining us this morning for the second edition of the Data for Decision Making Offshore Wind Energy Areas in Geoscience Survey Results Workshop Series. My name is Claire Kleinecht. For those that don't know me, I'm the Research and Engagement Officer with MRC, and I'm going to be hosting the session today. MRC is really excited to be partnering with the Geological Survey of Canada, as well as folks at NRCan for this workshop series, covering geoscience survey results from all three wind energy areas included in the current call for bids process. So this includes Middlebank, French Bank, and Sydney Bight. And today we will be focusing on French Bank. For those that might be new to MRC, we're the National Industry Association for Offshore Wind, Tidal, Wave, and River Current Energy. Our goal is to champion Canada's growing marine renewable energy sector through advocacy, engagement, and education. And so, a key aspect of our education work has been a webinar series called Ask an Expert that explores Canadians' biggest questions related to offshore wind. And now we're excited to be sort of expanding our programming into new data for decision making series, connecting subject matter experts with those that need data to plan or participate in the growing marine renewable energy sector. So now I'd like to take a moment and recognize and acknowledge the traditional territories and Indigenous peoples of the lands from which we are gathering on today. I'm hosting this webinar from Mi'kmaq, the unceded ancestral territory of the Mi'kmaq people. Given that we're coming together to discuss offshore wind, I also invite us all to think about the impacts that renewable energy projects can have on Indigenous communities and how we can improve our own understanding of local Indigenous peoples and their cultures to ensure that marine renewable energy projects move forward inclusively and respectfully. Now, just a few quick housekeeping notes. First of which, this webinar is going to be recorded and will be posted to MRC's website and YouTube page. However, the recording is going to stop at the end of the presentation to ensure that the discussion period can allow for a more open conversation. The workshop will begin with a presentation, as I had mentioned, from our SMEs, followed by a long question and answer period. So we really want to make sure that you're able to connect you with the subject matter experts. There's a team of them here to help, and really the whole purpose is to cover this. So we encourage you to ask anything that comes to mind. Now I'm pleased to introduce today's speaker, Dr. Calvin Campbell. Calvin is a research scientist with the Geological Survey of Canada, where he worked on marine geoscience projects offshore eastern Canada and the Arctic for more than 25 years. His research has focused on seabed mapping, stratigraphic analysis, and geological hazard assessments. In addition to advancing fundamental work related to marine geological processes, his work has now supported the development of new resource models, informing environmental impact assessments, and helping guide decisions around marine infrastructure. He is currently leading a research initiative on shallow stratigraphy offshore Atlantic Canada, which is providing new insights into seabed conditions and how they relate to offshore wind foundation design. Today, he's going to provide us with an overview of what geoscience data exists, how it was collected, key findings, and ongoing research in the French Bank WEA. So thank you, Calvin, for joining us. Please feel free to take it away.
Great, thanks, Claire. I'll just attempt to get my presentation back up here. Let's see. Just let me know if it's once things
Sure
look
thing.
happy.
I think in the display settings, you'll just have to
Same issue. Okay.
switch the second. Yeah.
How about that?
Perfect. Looks great.
Okay.
Thanks, Calvin.
Thanks, everyone. As Claire mentioned, this is the second of these knowledge sharing webinars that we're doing this week. My focus area is the French Bank wind energy area, and as Claire mentioned, my name is Calvin Campbell. I'm a research scientist with the Geological Survey in Dartmouth, Nova Scotia. Just first, a few acknowledgements. There's several GSE staff working on this program and these activities. They're listed there. I'm not going to go through them by name, but just to point out that this is very much a team effort. And there's a lot of experts contributing to this work. I also want to acknowledge the various captain and crew members and scientific staff that have participated on the field work that we've undertaken so far. We've had at least 12 expeditions since this program started in 2023. We also rely heavily on the Canadian Hydrographic Service with DFO for a lot of the mapping work we're doing. And then internally, we lean on heavily folks from our geoinformatics group, marine engineering and technical services group, as well as lab and collection staff for getting this work out. We also rely on collaborations across other GSC programs, which I'll mention in a subsequent slide. So just a brief outline. I'm going to present a bit on the Geological Survey of Canada, the organization, as well as the GSC's Marine Renewables Program and the structure, talk a bit about the data and methodology, and then get into the preliminary results from the French Bank Wind Energy Area, provide a bit of a summary. So Geological Survey, or the GSC, we're the oldest government scientific organization in Canada. We're actually 25 years older than Canada. We're one of we've been there since the start. We have about 500 staff that work with the Geological Survey. We have 8 divisions across the country, and each division sort of has its core area of expertise, but we do all work sort of in a matrix system where any individual researcher or staff member in any of these offices could be working anywhere in Canada. And we have over 45 specialized laboratories across the country. And really, our primary mission is to provide the geoscience knowledge to inform decision-making. Decision-making that involves Canadians, involves economic growth, involves effective environmental management, and public safety and land use. In terms of the marine geoscience that the Geological Survey does, the bulk of that work takes place at the Bedford Institute of Oceanography in Dartmouth, Nova Scotia. We're co-located with the Department of Fisheries and Oceans there, as well as the Coast Guard and the smaller presence by ECCC. We also have a sister institute on the West Coast in Sydney, BC, the Institute of Ocean Science. There as well, we have a division that primarily focuses on Western Canadian offshore work and in the Western Arctic. We work in all 3 of Canadians' coasts and oceans. We collaborate closely with other government departments and agencies and universities and other external collaborators. And essentially, the GSC programs are spread across 3 main themes: sustainable development and public safety, offshore natural resources, and ocean governance within the marine area of research. And really, a lot of our work falls into 2 broad categories. We do regional geological mapping, and then we do case studies to understand processes or products in a more detailed manner. In terms of the Marine Renewables Program, this program kicked off in 2023. It's a 5-year program, so it goes to 2028. A lot of the Geological Surveys programs run on a 5-year funding cycle. Currently, the bulk of the funding for this program comes through the Offshore Wind Pre-Development Program that was announced in Budget 2023. We do receive smaller amounts of funding from other locations within NRCan. And because marine science is expensive, we do leverage other marine science programs within the GSC, specifically the Marine Geoscience for Marine Spatial Planning program that has a lot of overlapping geographical interests. So, as I mentioned, a variety of funding sources for this Marine Renewables Program, and as mentioned, it goes to 2028 currently. And the main goal of the Marine Renewables Program is to provide marine geoscience knowledge and data to inform decision making. It falls into the general arc of what the GSC's core mandate is. We're really trying to fill critical knowledge and data gaps, and the goal of helping to set enabling conditions for offshore wind development in the Atlantic region. So, as many on the presentation are aware, offshore wind farms have a variety of infrastructure components that either sit on the seabed or penetrate into the seabed. Ranging from various foundation types to infrastructure that sits along the seabed. And this also involves connecting those offshore assets to the shore So you're going through a range of environments, a range of water depths, and a range of subsurface conditions. So in that sense, the main sort of themes that we're looking at within the program are bathymetry, superficial geology, the subsurface geology, engineering characteristics, sediment mobility within these wind energy areas, hazards such as underwater landslides, gas, salt, boulders, and anthropogenic features as well. So the program is structured with a number of activities. The activity leads are shown there. If you were at the presentation yesterday, you met Pierre Desiage. There's myself, who leads the quaternary sediments. Pierre leads the geological hazards and geoconstraints. Genevieve Philibert leads the superficial geology activity. Jordan Emer, besides being the project lead, is the geotechnical properties lead. Mike Lee leads sediment transport activity, and Lynn Defoe leads the bedrock component, and Natalie Shea is our program manager. So I'll also mention at this point, we do have a major mid-program report that's currently going through our publication system. It's approaching release date. We had originally targeted the end of March. That might be a little bit ambitious. The report's written and it's basically going through its editorial phase right now. So it should be coming out soon. And associated with that report is the release of a number of data sets on our geo.ca website. So that's a website for delivering geospatial data. And when those are out, we'll send the announcements out to the various channels. So I'm going to speak briefly about some of the survey and sample data that we have at the Geological Survey. We've been around for a while, as I mentioned. The marine component has been around for over 65 years. So we have a lot of legacy data sets that are relevant for this offshore wind work. A lot of our data and metadata are served through our expedition database. So that includes things like cruise reports, station data, geophysical survey data, analytical results, and that's accessible through the URL there at that bottom right side of the slide. Or if you just Google the expedition database, you'll likely get it. We have a huge collection facility at the Geological Survey where we store both an ambient and cold storage core samples. We have other sediment samples that are stored in our collections. We have bedrock samples, and we have a wide range of archived data and non-digitized metadata for the various samples and surveys that have occurred in the past. One of the components of this work that we're currently doing under the Marine Renewables Program is doing a quality control of a lot of those legacy data sets. In this example is the quality control of the grain size data that sits in our database, and that's sort of a bit of a buyer beware message for those that might be using these data sets. Certainly as technology has changed, navigation systems have changed, lab methodologies have changed. Some of the accuracies within these data sets require some QC, and that's currently underway by us to look at updating those data sets. So just a bit of a caveat there. We also have a number of sediment core and geotechnical lab facilities at the Bedford Institute. We have an X-ray CT system that allows us to do CT scans of our core samples, get very detailed 3D CT reconstructions of our cores. We have multi-sensor core logger, which allows us to do very detailed physical properties measurements on the core samples, as well as geochemistry through micro XRF analysis. We do, as a standard, also do miniature shear vane measurements on the split cores. So we have down core shear strength measurements from the lab. We measure discrete acoustic velocity parameters. We also subsample cores for things like grain size analysis, radiocarbon dating, etc. We also have a geomechanical laboratory that has 2 triaxial systems and 2 consolidation testing systems for doing advanced geomechanical testing on the core samples. And in some cases, we do send samples out for external analysis. 2 examples here for XR X-ray diffraction and for carbon-14 dating. In terms of the superficial data that we collect, the sample data, we do grain size analysis and subsamples. We do the full suite of grain sizes between laser systems to larger grain size analysis. This work is in progress on the new data between analysis on new samples and well as QC on the legacy data. And right up to visual analysis from drop camera photos to look at larger grain sizes such as boulders and such. XRD and XRF analysis are being done on selected subsamples. Again, some of this is done externally, some of it is internally using our own components. And we are doing from the drop camera data sets that we've collected some opportunity-based habitat work led by Vladimir Kostelev, as well as more broadly boulder identification that is sort of beyond the resolution of some of our geophysical tools. As mentioned earlier, we have been busy collecting data since mid-2023. We've had 12 expeditions, hundreds of stations collected as part of this work, comprising superficial and core samples, photos, mooring deployments, and so on. We've collected tens of thousands of kilometers of sub-bottom data, a lot of that coincident with multi-beam bathymetry mapping. And in that same theme, we've collected hundreds of thousands of hectares of new multi-beam mapping data. And we're now starting to look at these long deployment of mooring and lander deployments to look at sediment transport and current conditions in these wind energy areas. So that's a bit on the background of GSC and the data that we collect. I'm now going to go into a series of slides that talk about specifically the French Bank wind energy area. So beginning with the superficial geology. So again, led by Geneviève Philibert and others in this activity, we look at regional sedimentation within the wind energy area, the geomorphology, and in some cases, we're looking at automating some of the mapping processes. So the French Bank wind energy area, shown here in the outline, it's a relatively small bank, French Bank itself, and it's a deep bank. The shallowest water depths on French Bank are about 80 meters, maybe a little bit shallower. It's formed in part by a feature known as the Country Harbor Moraine, which is this curvy linear bathymetric feature, which is a glacial moraine that formed during the last ice age when the entire shelf was glaciated. It's a location where essentially the ice sat for a prolonged period of time and built up this curvilinear deposit. The wind energy area also spans, besides the bank, it spans the basins to the north and south, which extend down into water depths over 200 meters in the north and just beyond 150 meters in the southern part of the wind energy area. We've been collecting through our collaborations with CHS and ourselves multi-beam bathymetric data in the wind energy area. We have about 47% of the wind energy area completed. We have coincident backscatter information with that multi-beam bathymetry. And then sort of near shore from the wind energy area towards the northwest and towards the coast, there's a fair amount of existing either marine LiDAR or near shore multi-beam bathymetry as well in this area. In terms of superficial sample data that we collected for the superficial geology mapping, we collected more than 80 Van Veen small grab samples in the wind energy area, 68 of them actually within the boundaries. 5 IKU samples. We have a number of photos and subsamples of those grabs, and we've done 4 drop camera transects. So any one of those camera transects might have 30 to 50 bottom photos as part of the transects. And so these data sets, when combined with the bathymetry, form the basis for a lot of the superficial geology work. So the current state for French Bank, it's not as far along as the Middle Bank presentation from yesterday. Essentially, the standard currently for the area is Geneviève Philibert's 2024 regional superficial geology map. That's shown in the left inset there. That's available for download from our from our report serving system. Sort of in detail in the French Bank area, you see there on the right, it comprises essentially the full range from sand and gravel and till in the shallow areas down to post-glacial marine muds in the deeper parts of the wind energy area. So that's sort of the level of detail currently from the 2024 map. So the subsequent data that was acquired will lead to a much more detailed superficial geology map that'll incorporate the bathymetry, backscatter, the shallower components of the high resolution seismic, and the samples and images that we collected. Some of the new or interesting preliminary results, I guess, from the superficial geology mapping is some of the insights from the new multi-beam that has been collected in the northern part of the wind energy area. It shows a lot more greater variability and more clearly delineates the transition from bedrock to basinal sediments. Just want to show as an example here some photos from grab samples that have been taken on French Bank. Photo A and B showing muddy sand and cobbles and cobbles over silty sand. In a lot of places on French Bank in the shallower components, there's this veneer of coarser material over finer grain material in a lot of the samples that we've taken. And it just shows samples C and D, which are essentially at the same location, but show how variable it is even locally. So C showing basically the surface of pebbles and gravel at the seabed, and just immediately adjacent to that location, you essentially have a fairly clean stand with some pebbles. So it's highly variable on a local scale, I guess. So there'll be some refining of the superficial geology as a part of this work. I'm going to move on to the sediment transport activity. So this is led by Mike Lee. Really, for the French Bank wind energy area, we've primarily been focusing on refining the high resolution modeling of the significant wave height and wave period modeling for this area for the French Bank area. That's going to be the primary activity that we're working on around sediment mobility within the French Bank wind energy area. So currently no mooring deployments to help refine some of this work. As I mentioned, we are doing some opportunity-based benthic habitat mapping. This is led by Vladimir Kostelev, one of our research scientists in the program. We have about 22 legacy photo transects, legacy and recent photo transects. Essentially, what is recognized as two habitat domains. In deeper water, there's a lot of anemones, sort of deeper water benthic assemblages that are seen. Then in shallower water, there's a lot of which is a lot higher energy. There's coralline algae that are forming a lot of the pebbles and cobbles in the area, as well as two building polychaetes, as you can see here, these little branch-looking features that are in that photo. We'll move on now to the quaternary sediments. So that's the activity that I'm leading with a number of folks contributing to this activity. A lot of the output from the quaternary sediments work relies heavily on the subsurface imaging, so the seismic reflection and sub-bottom profiler data that we've collected. The French Bank area has been an area that's been sort of well studied in the past. It was sort of a case study area from the 70s and 80s to look at glacial marine and offshore glacial sedimentation. So there is a fair amount of legacy airgun data in the French Bank wind energy area. There's also a fair amount of new hull-mounted sub-bottom profiler data that we've collected as part of this work. And we also have a very high-resolution deep-towed seismic system that either the Huntec historically or the Geoforce deep-towed system that collects sort of higher resolution data compared to the single-channel airgun. So a range of subsurface imaging data sets. The smaller map in the upper right, where the circle is, shows the data coverage of historical data. There is a fair amount of legacy data over the French Bank wind energy area. The new data that we've collected since 2023 is shown on the larger map. Probably the most useful data that we've collected since 2023 is the Kongsberg hull-mounted sub-bottom profiler data, either from the RS Cook or Discovery. So it's a parametric system that does quite a good job imaging the sediments in the French Bank wind energy area. We also have coincident Knudsen hull-mounted sonar data as well, and a small amount of geoforce DTS data in the northern part of the wind energy area. We also have a lot of core samples, certainly compared to Middle Bank for the French Bank area, and that speaks to the fact that it's a much more happy place in terms of coring. It's a softer sediments, a lot more clays and silts compared to the gravels and so on that are in Middle Bank. So we have 24 sediment core samples. These range from piston cores to long gravity cores. We also have 27 free fall cone penetrometer measurements with a geotechnical tool that we use, and I'll speak a bit more about the geotechnics a little bit later in the presentation. So, as I mentioned, French Bank, there's a significant amount of research in this area from the 70s through to the 90s. It was the type area really for a feature known as a till tongue, or a definition of a geological feature known as a till tongue, which is a fairly unique glacial marine depositional feature. I bring up a cross section by Luke King and Gordon Fader from their 1986 GSC bulletin. North being to the left and south to the right, and the location of that basically that cartoon covers over that part of French Bank. You see the sort of architecture of French Bank. The black polygons are these till or moraine features. So the lenticular ones are the till tongues. The stippled bits in between are finer grained glacial marine sediments. And then this sits on top of on the southern side, on top of tertiary to Cretaceous bedrock. So the post-rift bedrock that sits underneath these quaternary sediments. And then to the left end of the profile, it sits on top of acoustic basement, which is likely Camero Ordovician metasediments, which I'll talk a bit about later in the bedrock portion of the presentation. But essentially what was shown in this 86 profile was pretty bang on in terms of the architecture. There's about at least 100 meters, in some places up to 200 meters thickness of quaternary sediments in the French Bank area, so a thick quaternary cover. And as I mentioned, they comprise till, so over consolidated in a lot of the cases, diamix, so anything from fine grained up to gravel and boulder sized sediments, as well as these till tongues that are these lenses that come out, which might be a bit softer, might be a slightly different composition. There's very little ground truth for the stratigraphy. And then we have stratified mud as the other primary facies that we see. So just for those that don't know or know little about the glacial marine geology, I guess what we're looking at here is during the glaciation, ice plowing the seabed, building up these moraine structures, which would be the equivalent to this country harbor moraine. And then adjacent to that, fairly high sedimentation rates, building up these thick successions of glacial marine sediments. So the profile I'm going to show here is a north to south or northeast to southwest Kongsberg parametric sub-bottom profile from some of the recent cruise work that we've had. This is profile A on the map, and it shows that if you flip that cartoon around that I just showed, essentially you have the country harbor moraine, or that thick moraine in the northern end. You have the more ice proximal glacial marine sediments shown here, these very nicely acoustically stratified unit, and then in the deeper waters from that, you have post-glacial sediments. We also see evidence of gas wipeouts in a lot of the thicker sedimentary successions in the French Bank area. I'm going to show profile B, which is here on the map. Again, same data type, the T's indicate these till tongues, so this sort of incoherent, acoustically transparent unit. Again, very little ground truth into this unit. A core from the 70s recovered coarse sand and a small amount of gravel. We tried vibrocoring in last fall, and we haven't looked at those cores yet. But interlaminated or interlayered with it is the glacial marine sediments. These stratified bits, which again are based on the coring results, which we have a lot more core samples, is alternating clays to fine sand. And I'm just going to show on the right here, this is a recent core sample that was collected last fall into the glacial marine succession. And it shows that. So that you can see the layering throughout the core. The darker layers are the siltier bits. There's a lot of sulfur reduction going on in the darker layers, but essentially alternates between clay or silty clay to fine sand. There is some evidence of microfaulting as well through the laminated succession there. Now, if we look northward into the northern part of the French Bank Wind Energy Area, again, this would be the Country Harbor Moraine or the morainal feature that covers the shallower part of the Wind Energy Area. And basically, you have a thick succession of glacial marine and post-glacial sediments in the basin. Again, we have some evidence of gas wipeouts through there, as well as some potential bedrock sort of popping up, forming local highs in the subsurface. Again, very recent core results. These cores were just split within the last couple of weeks, but this is from a very long piston core. It's a 20-meter piston core that was collected last fall. This is about 13 meters into the subsurface, into the very well stratified acoustically post-glacial succession, but it does show abundant soft sediment deformation within the alternating clay to fine sand sediment. So there's definitely some deformation happening, whether that's due to loading or some other process. So if we look at the Quaternary stratigraphy, this new sub-bond beta that was collected, one of the things that it's fairly straightforward to do is just look at total acoustic penetration, which gives sort of a qualitative estimate of the overall attenuation or impedance of the subsurface. The blues there on the map are thicker or more greater penetration, and the lighter blues are less penetration. Essentially showing over 90 meters of penetration once you get away from sort of the coarser material on the shallow parts of French Bank. We can also map the post-glacial succession, so it reaches thicknesses over 20 meters, both in the northern basin and towards the south within the wind energy area. And one of the other things that we can do from the data that were collected recently is just put together a fairly simplified outcrop map. So what acoustic facies is the primary facies outcropping at the seabed. A in this case is the diamic or glacial till or the coarser sediments. B would be the glacial marine silts and some sand, and then C being the sort of the basal fill post-glacial sediment. So that gives an idea what the dominant quaternary fill would be within those areas at a very generalized scale. We'll talk a bit now about some of the geohazard and geoconstraint work that we're doing, led by Pierre Desiage. Besides the gas features that we mentioned, we've also been looking at the occurrence of boulders on the surface. So we looked at 70 grab samples and 4 camera transects. We found boulders in 9 locations, and those are the red dots that you see on the map there. The boulders associated with a wide-ranging mix of sand, pebbles, and cobbles, so they sit in amongst these other finer grain sizes. And next step is going to be trying to see if we can identify boulders from the multi-beam data, either from the depth and from the backscatter information from the multi-beam. Pierre is also looking at glauconite in the sediments. So glauconite certainly for some foundation scenarios is an issue. So far, he's primarily found it in the deeper channels within the French Bank area, so not a huge recognition of it in the shallower parts of French Bank. And there's ongoing analysis of the glauconite, both looking at in the subsurface from core analysis and then looking at what the source of that glauconite might be, whether it's locally derived or has it been transported into the area. Speak a bit about the geotechnical work that's been going on in French Bank. Jordan Emer leads this work. As mentioned, we have about 27 free fall cone penetrometer deployments in the French Bank wind energy area. That video there is showing the tool being deployed last fall from the RS Cook. It's about 1.5 meter long probe that pre-falls into the seabed and collects a variety of geotechnical parameters in doing so. I would say, is probably of limited use on some of the coarser and harder substrates, but in French Bank, where there's a lot more marine muds, we've had more success in terms of penetration and getting probably some meaningful results from the FFCPT. This map here shows the deployments of the FFCPT over the French Bank wind energy area. The numbers shown are in centimeters, the depth of penetration of the probe. So certainly in the marine post-glacial sediments and glacial marine sediments, we've been getting pretty good penetration, 1.7, 1.6 meters. And then as you transition to shallower water, you get much less penetration onto the harder substrate, often either bouncing off the seafloor or getting just 10 centimeters or less penetration. But the vectors shown are also depicts the force of the impact, and in general correlates well with the Philibert 2024 map. We do have a number of geotechnical cores that reflected last fall as well. So these are duplicate cores. So at each one of these core sites you see on the map, there's a duplicate geological sample that we were doing our standard suite of analysis on in terms of the physical properties and sediment shear strength and photography and sedimentology. These duplicates will be used for destructive testing in our geomechanical lab. So this gives us a nice complementary set of core samples, both for calibrating the FFCPT data, but also getting some meaningful results from the geological core samples. We move now into the bedrock. So Lynn Defoe is leading the bedrock work. Bedrock is likely mostly an issue in the northwestern corner of the French Bank wind energy area. We have 3 grab sample stations that were collected that recovered meta sandstones and meta siltstones. There's multi-beam bathymetry within the area that helps with some of the bedrock mapping. And then obviously this wind energy area is fairly proximal to the coast, and we have a fairly good idea what the onshore geology is, much more accessible. But it's the Cambrian, Ordovician, Goldenville, and Halifax groups that outcrop along the coast there. So very hard metamorphosed sedimentary rocks that we're trying to correlate into the offshore. So in terms of the multi-beam bathymetry, it shows a fairly rough bedrock locally, and just east-west trending folds and oblique faults that are seen from the multi-beam. So I'm just going to zoom in here on some of the multi-beam data. So the circles there are the sample locations that I mentioned earlier. On the northwest bit of the multi-beam, you can see the seabed expression of the bedrock. So you can see folds. You can see some of the faults that we mentioned. And the dashed yellow line is an approximate demarcation of the edge of the Mesozoic and Cenozoic succession that sort of onlaps or truncates against the older basement bedrock. So we look at one of the subbottom profiles across the bedrock in this location. again, this cartoon drawing depicting this. So the deeper suggestion shows the roughness of the bedrock. It's been infilled in places by quaternary sediments, but it does sort of peek through in a number of locations. And as you move closer to the coast, it's primarily bedrock with very little sediment. So from these, you can interpret dip orientations even in the subsurface. Allowing again to extend that bedrock correlation into the area. So the sample results, the grab samples that recovered large class of these metasandstones. They're laminated to bedded metasandstones. They're locally altered. The portable X-ray fluorescence data that were done on these samples show that it's consistent with the Goldenville and Halifax group. So it confirms that that onshore succession does continue offshore. There's ongoing petrography and geochemical analysis, as well as some dating that's going to be done on these samples from the bedrock activity. There is potential field data out here, so there is regional magnetic data that was collected. It's a 1 kilometer grid. I'll flash it up here. Essentially, it's at a much lower resolution than what we see in the multi-beam in terms of matching structure, but the structure that's in the multi-beam does roughly match the data from the potential field. So the folds match the regional trend we can see from the magnetics, and the other structural elements also match in that regard. So one of the things that might be is that dashed line that defines that zero edge might actually be a little bit further seaward than originally mapped in the mid-90s. A little bit on the nearshore geology in French Bank. So again, the French Bank wind energy area. There's fairly proximal to the coast, sort of within 40 kilometers or less in cases in terms of the wind energy area edge. There is ongoing superficial and shallow geology mapping occurring in this region. This has been led by Ned King, who's working on this part of the activity. So Ned's work includes depth and thicknesses of sediments, so isopacks, sediment classifications. In this area, the various harbors that mark the coast, Wine Harbor, Country Harbor, New Harbor, these were fjords. They're fjord features, so these fjords extend offshore. So they are often sediment filled. They form conduits that sort of tie the deeper water areas up to the coast. But outside of those fjords, essentially, you're looking at quite hard and rugose bedrock. And just showing that some of Ned's work here. So this is ongoing, moving towards a report coming in the next before the end of the program. I guess I won't commit Ned to more of a timeline than that. So just a bit of a summary. So in terms of the superficial geology mapping, a lot of this work in French Bank is ongoing. But we do have the data now to sort of revising that superficial geology map. Similarly, the sediment transport, the localized models of wind and wave and currents are being worked on. Again, the opportunity-based benthic habitat mapping is underway, and the more advanced work on the geoconstraints or geohazards. Again, it's coming. There are boulders on the surface here. There is glauconite in the channels. There's certainly evidence of gas. Similarly, superficial geology, the work continues. We're hoping to get a lower frequency seismic reflection system of these wind energy areas soon to do some more detailed seismic mapping. The geotechnical work, again, a lot of this stuff samples are just arriving back into the lab. And so it takes a fair amount to do the lab analysis and follow up and interpret those results. So that's forthcoming. As I just referred to the nearshore geology, that is work that's underway, as well as work on the bedrock geology is also underway. but there is a good match between what we see in the multi-beam and the regional trends onshore. I think that's it. Thank you.